Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today on What the FOOF, we're going to be discussing a class of chemicals known as mustards. Unfortunately, the best known mustard is mustard gas, a sulfur-based chemical that was used in the First World War due to its propensity to cause blistering and damage to the lungs. The chemical has a sulfur atom, coming off of which there is a CH2, a CH2, and a chlorine, and another one of these units on the other side. In fact, this CH2, CH2 chlorine, or potentially bromine, is seen in all of the mustards. The reactivity of this mustard gas comes about because there is a lone pair of electrons on the sulfur. This lone pair is perfectly positioned to keep trying to displace the chloride that's attached to that CH2 there. When it successfully does this, a positively charged triangle is formed. This is now very reactive towards other lone pairs. And you know where there are a lot of lone pairs? In your DNA. The nitrogen, for example. Its lone pair could come in, and when it does so, react with that triangle, and now we have this chemical attached to your DNA. And you'll notice on the other side of that sulfur, there's another CH2, CH2Cl, so it can form another triangle. And that triangle can once again find another nitrogen in your DNA and form a bond. Now we have two bits of your DNA being grabbed by a foreign compound. And when this happens, it can start to bend and change the shape of your DNA. The function of the DNA can then be affected. The division of the cells may be prevented. We could have uncontrolled growth, which is what cancers are. Or if the body notices that something weird is going on, apoptosis, programmed cell death, could occur. Or if you're actually very lucky, your body may notice there's something wrong and fix it. After the First World War, the Geneva Convention banned the use of mustard gas. But this didn't put an end to all research. And after the Second World War and the wartime secrecy was lifted, scientists revealed that they had been researching not sulfur mustard, not mustard gas, but nitrogen mustards, where rather than having a sulfur in the middle, they now had nitrogen. The lone pair on that nitrogen could also form that highly reactive, positively charged triangle species, which could then alkylate DNA, make another triangle and alkylate DNA again. But what they found with this particular class of compounds, now with the nitrogen, was that it would have a therapeutic effect on various tumors and cancerous growths. We think back to what I said before about what happens when your DNA starts to get these additional molecules added onto it. I said your body may notice and fix it, or it may notice and have to kill the cell. Well, in the case of cancer, something has already gone wrong and the body wasn't able to fix it. So more than likely, it's going to trigger that apoptosis, that programmed cell death. Another advantage that nitrogen mustards have over something like mustard gas is that nitrogen can form 3 bonds, whereas sulfur is happy with just the 2 bonds. If we have the 2 mustard moieties attached to the nitrogen, so we've got an N that looks a lot like mustard gas, but with a nitrogen, we still have another section where we can add what we would like. Different lengths of alkyl chains, other groups that might affect the solubility or properties of the drug, or even you could add a third mustard moiety and be able to have 3 alkylating arms. Unfortunately, these nitrogen mustards are quite non-specific. They hit a lot of different parts of the body. A lot of different cells are affected and harmed by them. In addition, because of their potential usage in chemical warfare, their production and storage is all very highly regulated. And so, although occasionally these very first ever discovered chemotherapy agents are still used, they've kind of been eclipsed by other more modern treatments. One such treatment is cisplatin, where we have a platinum with 2 ammonium groups and 2 chloride groups attached to it. Now, cisplatin interacts with DNA by losing one of those chlorine groups, attaching to a nitrogen in DNA, losing the other chlorine group, and attaching to a nitrogen in DNA. So just like a nitrogen mustard, it starts to deform and bend and modify the shape and the function of DNA. And it does so with less additional toxicity. I hope you have enjoyed this video. And if you have, please make sure to click like and subscribe and share it with your friends. And if you'd like to contribute anything to a discussion about what we've just talked about today, or you'd like to suggest a topic for a future video, please put it in the comment section below. Thank you, and I hope you have a wonderful rest of your day.